Hello everyone. Welcome to the AI for All channel. We will now talk about topics 2 and 3, the first practical steps. Next, we'll discuss 3 advances and challenges in the 1970s to 1980s. 2. The first practical steps. After the pioneering ideas about artificial intelligence, AI, proposed in the 1950s, scientists began to seek ways to implement these ideas in practice. They wanted to build systems capable of performing tasks that, until then, seemed to require exclusively human abilities, such as solving problems, learning from experience, and even playing complex games. These early practical steps in AI involved developing programs and algorithms capable of simulating human reasoning processes. One of the first examples of applied AI was the logic theorist, created in 1955 by Alan Newell and Herbert Simon. This program is widely considered the first AI software in history. The logic theorist was designed to prove mathematical theorems, which was seen as a significant challenge since it required the use of logic and deduction abilities typically associated with the human intellect. The goal of the program was to demonstrate that computers could, in fact, reason and solve abstract problems. Newell and Simon believed that mental processes could be simulated through a set of logical rules. The logic theorist was programmed to use these rules to find solutions to theorems of propositional logic, a branch of mathematical logic that involves propositions that can be either true or false. They fed the program with a set of theorems from a famous work by Alfred North Whitehead and Bertrand Russell called Principia Mathematica. One of the most remarkable moments of this experiment was when the logic theorist found a simpler proof for one of the theorems than the original solution presented in Principia Mathematica. This was a notable achievement at the time, as it showed that the program not only replicated known solutions but was also able to innovate, finding new paths and optimizing solutions. This type of behavior was exactly what researchers expected from artificial intelligence. However, the logic theorist also had its limitations. It was a system designed for a very specific purpose, solving mathematical theorems, and was not capable of generalizing its reasoning to other areas. Even so, the impact of this work was significant. Newell and Simon not only contributed to the development of AI but also helped lay the foundation for a new cognitive science that sought to understand the human mind in terms of computational processes. While the logic theorist was an advancement in terms of logic and reasoning, another important milestone in the early practical steps of AI was the perceptron, created by Frank Rosenblatt in 1958. The perceptron was one of the first attempts to build a machine learning system, where a machine could learn from examples without being explicitly programmed to perform a specific task. Rosenblatt's goal was to develop a machine capable of recognizing visual patterns, somewhat simulating the way the human brain works. The perceptron was a simple type of artificial neural network, a computing structure inspired by how neurons function in the brain. It was designed to process information in a manner similar to a network of biological neurons. Essentially, the perceptron worked as a supervised learning machine. It received inputs, such as images, was trained with examples of patterns it should recognize, and then attempted to classify new inputs based on what it had learned. The great innovation of the perceptron was the idea that a machine could adjust its own parameters to improve its performance over time. During training, the perceptron automatically adjusted its weights, the values used to determine how the inputs should be processed, based on the errors it made, much like how humans learn from their mistakes. This concept of adjustable learning is one of the foundations of modern AI and remains a central feature of many current machine learning algorithms. However, like the logic theorist, the perceptron also faced significant challenges and limitations. In 1969, Marvin Minsky and Seymour Papert published a critical analysis of the perceptron, demonstrating that it was incapable of solving relatively simple logic problems, such as the famous XOR problem, exclusive OR, where two variables need to be compared so that only one of them is true to produce a positive result. This criticism cast a shadow over neural networks and slowed the development of technologies based on them for many years. Nevertheless, the perceptron and the logic theorist opened doors for a new era of exploration in the field of AI. While most systems developed in the 1950s and 1960s were highly specialized and limited in scope, they established fundamental principles that would prove crucial to AI development in the following decades. One of the greatest challenges faced by these early AI systems was the lack of computational power. The machines of the time were slow, had limited memory, and were unable to process large amounts of data, which restricted what could be achieved with these early programs. Moreover, the lack of structured data hindered the proper training of machine learning systems. The concept of big data, so crucial to modern AI, was still far from being viable at that time. Despite these limitations, the 1950s and 1960s were a time of great optimism for AI pioneers. They believed that, with time and the development of better computers, machines would be able to perform increasingly complex tasks and come closer to human intelligence. This confidence was one of the main driving forces behind the field in its early years, and although many of these early dreams took time to materialize, the foundations established during this period continue to influence modern AI. 3. Advances and challenges in the 1970s to 1980s. While the early years of AI research were filled with optimism, the 1970s marked the beginning of a period known as the AI winter. This term refers to a time when enthusiasm for AI development drastically waned, and funding and general interest in the field faced serious difficulties. But why did this happen? To better understand this period, we need to look back and examine the initial expectations and challenges that arose during these decades. In the late 1950s and early 1960s, scientists believed that, in a short time, machines would be able to solve a wide range of problems, surpassing even humans in certain areas. The idea was that it would only take refining the algorithms and increasing the computational capacity of computers to achieve these goals. However, this optimistic vision soon collided with technical reality. Developing a truly intelligent machine proved to be a far more complex task than AI pioneers initially predicted. One of the main problems faced at the time was limited processing power. The machines available in the 1960s and 1970s simply didn't have the necessary processing power to execute the tasks required by AI algorithms. Additionally, many of the early AI programs relied on large amounts of data and memory, which were also scarce during that period. Without the necessary infrastructure, scientists soon realized that they couldn't make significant advances with the tools at their disposal. Another major obstacle was the problem of complexity. The early AI algorithms were based on explicit and logical rules, which worked well for solving simple mathematical or logical problems, as in the case of the logic theorist. However, as researchers tried to apply these algorithms to more complex and realistic problems, such as natural language interpretation, pattern recognition in images, or navigation in real-world environments, they began to encounter insurmountable limits. Next topics. For the AI Renaissance in the 1990s to 2005, the revolution of deep learning and modern AI. Did you enjoy the content? Don't forget to subscribe and like the AI for All channel to stay up to date with the latest in technology and artificial intelligence. See you next time.